Hello guys. So today we are going to solve the practice set, and most importantly in the practice test, the question 1, question 3 and question 4 everyone has solved correctly, but the question 2 I think was a very tricky question. So this question most of them gave the answer to be like 5 course. So let's understand the logic behind like what this question actually is saying and what kind of answers you guys should have given. Okay, so let's read the question first. So the case study is talking about a cafe in Texas, and this cafe has noticed that some customers have initially shown some interest in their cold coffee, but to prepare this cold coffee and serve it, it is taking 15 minutes of serving time. Now there are customers who are having very less patience, and these customers leave when the waiting time is like 45 minutes for them. As of now, the infrastructure the cafe shop has is it has 3 coffee delivery counters, and it is trying to increase the number of counters so that there is a peak time for them, which is 9:30 a.m. to 10:30 a.m. Okay, where there are more number of customers. Now, how many customers they are having at the peak time is 20 customers. Now, the owner has contacted us and he wants to know how many coffee counters he will be needing so that the customer will be waiting for less than 30 minutes or equal to 30 minutes. So we need to help the cafe owner. So let's frame the problem first. Okay, so in the initial stages we are having coffee counters. So this is one, this is a second coffee counter, and this is a third coffee counter. Now let's see why the time has increased to 45 minutes actually. Now let's say we are having one customer. Okay, and we are having another customer here and another customer here. So to serve these 3 customers, how much time we will be taking? So we will be taking 15 minutes. Now let's double the customers. Now the first customer will get the coffee at the 15 minutes, and the next customer will be waiting for 30 minutes. So to serve all these customers, it will be taking 30 minutes. So we are having 6 customers and we can serve them in 30 minutes using 3 counters. Now let's increase it to 9 customers. So now this customer will be waiting for 45 minutes. So for 9 customers, when we are having, so this customer, and this customer will be leaving. So we can see that having 3 coffee machines and reducing the waiting time to 30 minutes, we can only serve 6 customers, not 9 customers. And if we increase the number of customers, we will not be able to serve with 3 coffee counters. Okay. Now let's increase our coffee counters to 4 and see what will happen. So here we are having let's say 3 more customers. Still, again, the customers will be leaving. Even though we are having 9, 6, 9, 12 customers, okay? Again, the last customer will be waiting for 45 minutes. So in the same way, let's increase our counters to 5. Now here, so even though we are having 5, the last customer will be waiting for 45 minutes, because this customer will take 15 minutes, this customer will take 15 minutes, and he also like the last customer will also have to take 15 minutes. Now we can see that having 5 of them, okay, is not an optimal solution. Okay, now what would be the optimal solution? Making the last customers waiting time to be less than or equal to 30 minutes. Okay, so we know that if the queue is like this, like 1, 2, 3, it can never be 30 minutes. Okay, so what we have to do is increase the number of coffee machines. So if I make it 6, okay, and let's say we are adding more 3 people here, so we are having total 3, 6, 9, 12, 15, 18 coffee, sorry, 18 people. Still we are not able to serve with 6 coffee counters. Now let's increase it to 7. Now in case of 7, what is happening? We can just take 1 and 2. Okay, so this coffee counter will serve the customer in 30 minutes, but again these customers will be waiting for 45 minutes, the last customers. Now if I increase it to, let's say we are having 4 and 7 coffee counters, okay, now this person, he can go to this counter, okay, and let's say this person will go to this counter and he will also get served in 30 minutes. Now let's increase more. Now I can just bring this person who was waiting. Let's remove him. Okay, this person will come here who was waiting, and this person will come here, and these people will be served in 30 minutes. And the last coffee counter, if you take, this person will go here and this person will go here. Now when you have 10 coffee machines, okay, what is happening? The first person will wait for 15 minutes, second person will wait for 30 minutes. So the last customer is waiting for only 30 minutes. So our condition was to reduce the time to less than or equal to 30 minutes. So no customer will be leaving, okay, when you are having 10 coffee machines. So what we will suggest the coffee shop owner, that he should be using 10 coffee counters. Right? So this is the solution. Okay, I hope you understood, but as few people were not in the class, I wanted to give another case study in this video so that people can solve it. So now this case study is kind of like interesting. So we are having a website, and this is a website which sells clothes online. Now, to buy a particular cloth or particular dress, okay, a customer takes a time of his minimum time is 2 minutes and his maximum time is, let's say, 5 minutes. Now we are getting this traffic to the website, and here we are having, let's say, for one day the site has some 1,000 customers, and as of now the website is using only one core which can handle 200 customers. Okay, so now the website owner wants to know if he wants to serve all these 1,000 customers, okay, initially, okay, how much time he would be taking. So one core one core can handle 200 customers. Okay, that means you have to use this core 5 times for 1,000 customers. Now let's calculate a basic overview, like how much time he's taking as of now and how much he wants to reduce. Okay, so as of now you are having 200 customers, one core, so it will be nothing but 200 times 5. Let's take the worst case scenario, like we always take the worst case scenario. Even in the previous problem we were thinking of the worst case scenario where if people are going into the counter, okay, what is the last person's waiting time. Now the same thing we are doing here, we are taking 5 minutes, okay, and this will take 1,000 minutes. Okay, now this is for one core, sorry, one 200 set of customers. Okay, now how much you are having in total? 1,000 customers, so it will be nothing but 1,000 times 5, which is 5,000 minutes. And when we just convert these two hours, will be nothing but 5,000 divided by 60, which will be approximately somewhere between 80 hours. So let's just take it to be 80 hours, or we can like calculate it, which will be somewhere near 84 hours. Okay, now if there is only one day and it is taking 84 hours for these many customers to be buying the clothes, so it's not a proper way for the website to work. Now the person wants, or the client wants, to decrease the time to less than 7 hours. So you have to answer how many cores will be required to reduce the whole shopping, like 1,000 customers to buy anything from this website to less than 7 hours. So this is the question. uh, please solve it, and if you have any doubts, contact us. Thank you.